Hey everyone, and welcome to this video for P80-105, a course on data science. This is the third in a collection of 3 videos on data visualization and exploratory analysis. And in particular, I'm going to be talking about exploratory analysis using numeric summaries of groups and subgroups. I'm going to start by giving an introduction using slides, and after that I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful, and to get the most out of this, I encourage you to try to code along with me. All this material is available at p8105.com. There are links in the description below. Awesome, let's get started. Great. So we're going to talk about exploratory numeric analysis, and I want to be a little bit clear about what I mean by that. We've been in this collection of videos talking about exploratory analyses, and the first two focus mostly on visualizations as a tool for both exploratory analysis for understanding the data that's in front of you, and also for communicating some of those things. I've said in a prior video that exploratory analysis is really a loosely defined process, and that almost anything that exists between the time that you import your data and the time that you conduct the formal analysis that you're going to report could in some sense be considered exploratory. We've talked about visualization. Some of these are going to be checks on completeness and reliability. You want to know where your means and your variances are. You want to get some idea about whether or not there are group differences in key variables. You may use this as a process that generates new hypotheses, or at least gives you some sense about what's going on. Because exploratory analysis can be so broad, we're sort of by default not really going to talk about everything. If your final analysis is a really complicated analysis, your exploratory analyses might include some pretty advanced things. You might be running regressions, you might be doing some machine learning, some principal component analysis, some statistical learning approach. That can count as exploratory analysis depending on sort of what your ultimate product is. In this case, we're sort of taking a very simple approach to exploratory analysis in the sense that what we're going to be focusing on are producing numerical summaries of data, quantitative things, especially things like the means and the medians and the variances. And we're going to look at those things within groups and then within subgroups. And so in this sense, it's sort of exploratory at the very initial steps of doing some kind of exploratory analysis. Now, I've said we're going to be interested in groups and subgroups. Data sets often contain, either by design or by implication, some kind of a grouping structure. And you can think about this first as like categorical variables could be used to produce groups. You might be interested in differences across racial groups or gender groups, or you might be interested in geographic differences. You might want to know things about age groups, where you might treat age as a categorical predictor every 5 years or every 10 years, something like this, rather than as a continuous variable. Again, to do some exploratory kinds of analyses. And in each of these cases, that grouping information is going to be important to you potentially as you want to understand the distribution of other variables. And as you want to know something about, say, health outcomes or BMI or whatever it is you're interested in, you might want to do some within group analysis and then do some comparison across those groups. You can end up in cases where groups are nested. You might have, for example, a geographic group and then a family group nested within a geographic group. That's fine, and indeed that can give you some idea about what's going on at sort of multiple levels of a structure. These are often groups that you want to examine both visually and quantitatively. So again, if you're looking at a categorical predictor, you might have something like a box plot that gives you some information across multiple groups. And that's the sort of thing that we're going to be interested in here as well. But the production, not just of visualizations, but of numeric summaries of how these groups work. And so I say then grouped summaries. Very often what we're interested in is computing some specific summary, take some variable that we have in our data set, for example, and say, what is the mean of this variable across racial groups or across geographic groups or across some other group that we're interested in. You might use the median instead. If you have a binary outcome or something like this, you might want to compute, say, the percentage of men or women inside of one of these geographic groups for whatever reason. These are the kinds of summaries that you might want to produce if you're interested in what's called a measure of center. You might also want to know things about the variability. You could compute a standard deviation or a variance or an interquartile range. I'm also saying here that you might want to know whether or not there are different amounts of missing information for some variables across the groups that you're interested in. That can be informative, for example, if you get different amounts of response or follow-up or selection within some of these groups. I'm not in this class, again, sort of one of the things that I've said is that most of this the collection of videos, most of this course really, is not so much interested in making sure that you understand the relative merits of means and medians and the definition of a standard deviation or an interquartile range or a variance. I'm sort of assuming that you are learning those things either in parallel to this or prior to this, but I'm not going to spend a lot of time talking about any of those things in particular. I'm instead going to sort of assume that knowledge exists, and we're gonna worry about how to implement it in some of these analyses. So how are we actually going to do these things? Fortunately, I've been talking about grouping and summarizing, and there's a really easy to remember collection of functions, pair of functions, that allow you to do this kind of an analysis. So in particular, with a data frame, we are going to add a layer to that data that defines groups, and then we are going to use summarize to compute summaries within each of those groups. Now, both of these are sort of based on existing variables in your data set. So you would group by, for example, some categorical variable that exists in your data set already. It's not going to change any of those values. It's not going to change values for anything else. It doesn't change your data so much as it takes that data frame and adds a layer on top of it. And that layer is something that gets interpreted by later functions, in particular things like summarize. It, again, doesn't change your data, but adds some component that summarize can use to understand a grouping structure in the computation of summaries. It also gets picked up in some other functions. It shows up in mutate. It shows up occasionally in plotting, I think. And I say here that it's not exactly invisible, but it is easy to miss. And sometimes, often, when I've been particularly puzzled by a R output or an error message, it has turned out to be the case that I had some grouping structure that I forgot about, and that caused havoc. It wrecked some later code in a way that wasn't always clear. And so I'm mentioning this just so that you're aware that grouping sort of persists and can end up being causing problems in later code if you've sort of forgotten that you've grouped things. But suppose you've grouped things and now you want to move on to computing summaries. Well, that's what summarize is going to be useful for. So you're going to say, with these groups for this data set, please compute the mean of this variable. And it will compute the mean in this group and in this group and in this group. And then whatever other summaries you need, maybe you want the mean and the standard deviation. You're going to compute both of those. And what you end up with is then a data frame that's got your grouping levels and the summaries that go along with it. And it's helpful, really, that this ends up being a data frame, right? Everything's sort of in the tidyverse. You start with a data frame, and at the tail end, you still have a data frame. And so here, you can compute these summaries that you are interested in as part of some analysis. Sometimes it's the final step, and you end up needing to do some transformation to make that a little bit easier for a human to read. You want to organize your output into a table, for example, but sometimes that's something that goes directly into the next step of an analysis. And so having group by and summarize operate nicely in the context of these sort of piped operations that we've seen in the past, where tibbles go in and then tibbles come out the other side. That's really going to be useful in a lot of settings. I am going to give some word of caution. As I said, this is not the primary emphasis of this course, but I would sort of feel, I'd feel bad about myself as a statistician if I didn't at least mention some of these concerns. In doing exploratory data analysis, I guess I want to be clear, you should often have in mind some formal analysis that you're going to do, and the exploratory analysis is sort of there for you to learn a little bit about your data and maybe from your data, but without changing what that formal analysis is, depending on sort of how you're going to do things. And what I mean by that is, if you plan to report p-values, you should have those specified in advance, because the reporting of a p-value sort of depends on that being the test that you have decided that you were going to do, and that you're not sort of worried about all the prior tests that go into that, all the sort of learning that gets you there. If you are generating hypotheses on the same data that you are then formulating a hypothesis and reporting a result, very often that final p-value that you get to isn't valid at all, not even close to valid, because you sort of made a variety of choices in your exploratory analysis before getting to a final analysis. And that's sort of well understood as an issue in how you might do data analysis, and knowing that the final p-value that you get the validity of that final p-value really depends on the process that got you to that point and whether or not the assumptions that underlie a specific p-value are something that are valid. And so again, when you start thinking about exploratory analysis, I think it's important to know that at some point, if you plan to do a real formal analysis, then you need to be careful about that. And maybe that's not something you're interested in at all. Maybe with the data you have, you are just interested in seeing what's there, but not drawing real firm conclusions about anything in particular, in which case, fine, knock yourself out. But if you're going to report some formal analysis, you need to make sure that the things that you're doing are correct and statistically valid and appropriate, and a variety of other things. And again, I'm sort of warning you about this problem, but it's not going to be one that we solve in the context of this class. Like I say, I want you to be aware of it, and now is a good time to mention it when we're thinking about exploratory analysis. So with that said, we're going to sort of shift to seeing how you might do some of this grouping and summarizing, and we're going to shift to a screencast now. All right, here we go. Time to do some code. I'm going to get started again in the same project, directory, repository. All of that is sort of already set up. And again, before starting this video, I duplicated the viz2.rnd, the one from the second video in this collection of 3. I've copied it and updated it here. It's sort of renamed to EDA, and I'll sort of take a look at that now. So let me open up my project and the EDA RMD file. I've renamed it Exploratory Analysis. One of the first things that is different here in comparison to past R Markdown files that I've looked at is this whole collection of stuff right here at the beginning. If you remember in the second video, I talked about how I like to set a variety of options at the outset of my R Markdown documents, and that's what this does. It sort of defines figure widths and output ratios and output widths, aspect ratios. It defines the theme for ggplots and sort of defaults to the Viridis color palette. All of that is something that I just copy and paste from the beginning of one R Markdown file to the next one so that I never really have to worry about it. The next thing that happens in this R Markdown file is loading this weather data set that we've seen a couple of times. There's one small addition here, which is that at the very end of this mutate statement, I have added a line that extracts a month variable. We've gotten the date in the past, and we've sort of looked day by day at things that are going on. And without getting into too many of the details here, I'm using the lubridate package. The lubridate package is one that's sort of tidyverse adjacent. It's written by the same people, but it's not in the tidyverse. So it's a tidyverse adjacent package. And here I am saying, get the floor of a date and sort of round whatever date, sort of pull every date down to the nearest month, sort of in a pulling down fashion. So let me run this and maybe it'll be a little bit more clear what's going on here. So I've got the tidyverse, I'm importing my data, and now let me take a look, right? So I've got Central Park we've seen, we've got the ID, we've never really used, it's sort of synonymous with the name. We've got dates, January 1st, 2nd, 3rd, 4th, 5th, precipitation, Tmax, Tmin, and the here month is just rounding whatever date down to the first date. There are probably other ways that you might do this exact same thing. I'm not super worried about that piece of things for now. It's just sort of helpful to have a month variable that we're going to play around with. All right, so that's all my setup, and what I'm going to do now is introduce group by. All right, in this data set, I think I've got a variety of things that are sort of plausible grouping variables, and what I mean by that is I at least have 3 weather stations, and so I could view the data that I have as grouped by either grouped by Central Park and Waikiki and Waterhole, 3 groups. I could also view these as grouped now by month. I could say I've got data for January and February and March and April and the rest of the months, right? Like that's another grouping option. I could also group by both so that I have within Central Park, January, February, March, April, May, and then within Waikiki, the same thing, January, February, March, April, May. I can do that grouping, and that's helpful. And so the first thing that I'm going to do is just show you what grouping looks like. So I'm going to take my weather data frame, and I'm going to pipe it into group by. Again, group by is a tidyverse thing, data frame in, data frame out. And I'm going to group by name first. And let's just see what happens. And this is a little bit strange in the sense that it kind of looks like nothing happened, right? That's sort of where we are right now. We've got the same data in the same order and all the values are the same. What's different is you notice there's a special little line right here that says there are now 3 groups defined by the name variable. And in that sense, grouping can be easy to miss. It doesn't change your data set, and unless you're paying real close attention, you might not realize that there is a grouping structure layered on top of a data frame. But there is now, and some subsequent functions, when you get to mutate or you get to summarize or something like this, those functions will take into account the grouping structure that you've introduced. So you do have to sort of be aware of when you have grouped and when you might need to ungroup, but it's a useful thing to do. And let me just sort of point out, we can group by name and month. And so here I should have 3 stations in 12 months, hopefully something like 36 groups. And yep, I get name first and then month and then 36. And I'm not changing my data per se, I'm just sort of adding a little bit of additional information on top of this. This is a weird thing to do sort of immediately after, but I can also ungroup. I've said that grouping, by virtue of being invisible and also changing things that happen down the road, it can sometimes mess up whatever it is you're doing. So imagine here I've done some additional analysis for whatever reason. I've mutated or summarized or something like this. And then eventually I want to ungroup the result. So if you group and then you ungroup, ungrouping gets rid of whatever grouping structure you have. And I think you can ungroup, for example, by 1 variable at a time, and it will retain whatever that other grouping you wanted to have. So that's helpful to know. Okay, I haven't done anything, but let's go ahead and knit and commit just in case. Always good to commit. All right. So what I'm going to do next is, one of the first ways that you might go about summarizing things is to count them. So let's try counting things. When I say counting things, I mean you might, in looking at your data, want to know how many observations do I have for Central Park? How many observations do I have for January? How many observations do I have for Central Park in January? Right? These are the kind, when I say counting, I just mean how many blank exist. Counting is a thing that you do a lot of, and so there are a variety of mechanisms to do it. The first one I'm going to do does include group by and summarize. So let's count month observations. And what I mean here is I'm going to take my weather data frame and I'm going to group by first month, and then I'm going to use summarize. And here again I have to define how I want to do this summarization and what I'm hoping to do with it in the end, like what is the actual process I'm going to use. And so I'm going to name the outcome that I want to obtain. I'm going to say I want to compute the number of observations, and then I need to define some function that tells me, well, what am I doing here? And in this case, for counting, there is a handy function, the n function, that just says, well, what's my n in the current group? What's my n right now? And so if I group by and then summarize in the number of observations, I get 93 observations in January, 84 in February, 93 in March, and so on, right? And that seems sort of like it's working. And here again, I've got nobs is the variable that I've created. I have retained the groups that I'm interested in, and the end result here is a tibble. I've got a data frame so that if I wanted to use this some other time, if I wanted to make a plot out of this, I can pipe this directly into ggplot and it's going to work just fine. So let's see, for example, what happens if I group by name. Well, I've got 365 observations for each of those things. What happens if I group by name and month? Well, it gets a little bit larger, but I've got 31 days in January and 28 in February and 31 in March and so on, right? This is all, I'm counting days. It's maybe not the coolest thing in the world, but it is helpful to sort of take a step back and understand group by first and how you're going to define the grouping variables that you're interested in, and then summarize by naming a variable and defining a function. That is the basic strategy for month and name. That is the basic strategy for using group by and summarize. Since we're counting, we can use count as well. Count is sort of a shortcut if the grouping and summarization that you're going to do is just adding things up or just counting what's available. So here I could, for example, say weather data frame, pipe that into count, and I want to count, let's say, observations in the month column. And let's say that the name of this result is going to be number of observations, right? It sort of does the same thing. You might be able to count by name and month. Again, if you're sort of counting things only, this count function is synonymous with using group by and then summarize. I'm going to say never, let me sort of make this clear, never use base R the table function. And so this is the sort of thing, like if I catch you in an R Markdown file using table, I will like, it'll hurt me in my heart. The reason is sort of the following. So I guess sort of to be clear, this is if you are somebody who has used R in the past, or you sort of come across this somewhere. Why am I saying don't use table? So I could pull the month column, right, and get a long list of all of the months that exist, and then I could put that directly into the table function, and it's going to count out, well, in January you've got 93 months, and then in 93 observations, and then in February you've got 84. And again, this is like almost painful for me to look at for two main reasons. The first is that the result of this is not a data frame, and you're going to end up not being able to use whatever it is you have been interested in some subsequent analysis, right? Like whatever this table is, it's not helpful. It's really a hassle to do anything else with. And the other reason is that to get to the table function, I have sort of had to start from a data frame and then take a variable out of a data frame, which again is just in general a bad idea. If there are extremely rare cases where you have to do that because there is some base R function that only works if you're doing this vector thing, but you don't have to do that in this case, so don't do that in this case, right? So let's say just don't even evaluate this, and let's try to reknit. There are some other helpful files that exist, or sorry, helpful functions that exist in this sort of counting framework. So let's copy here, other helpful counters. And what I mean by that is let's sort of group by name first. Let's group by month first. So here I have 93 total observations. If I wanted to say, first, I'm going to sort of point out two things. If I wanted to say, what is the number of days, the distinct days, instead of n, I can use n distinct in the dplyr package, and it will count not just how many observations they are, but sort of in the same way that distinct tells you, just give me the ones that are actually unique. Indistinct is going to count the number of distinct observations. So let me run this. It says no. Oh, here I have to tell it what am I trying to count the number of distinct things of. I'm telling it indistinct dates, right? And so here there are 31 days. I have in this month group, I have 93 total observations and 31 unique days, okay? There are two things that are happening here that I think are useful. The first is that in summarize, I have given now two things that I would like to summarize. I've in summarizing created two variables, the number of observations and the number of days. So you can, and we'll see shortly, you can create a number of summaries when you do this sort of a process. The other thing that I'm noting is that even though we're still counting, you name a function, and sometimes that function depends on some other variable. So indistinct here is looking at all of the dates in this month, and then it's saying how many of those dates are distinct. So again, it's sort of looking in this month, in every observation in my data set that has this month, how many dates are distinct? Well, there's going to be 31 distinct dates. And I've said in and distinct and date enough times that it's starting to not make total sense to me anymore. So we're gonna move on from here. So let me knit this real quick. Okay. Awesome. All right, so the next thing that I'm going to do, and this is more or less a short digression. This is not the most critical segment of any of these videos to watch, but since we're counting things, and we're in a school of public health, I sort of have to talk about 2x2 tables. And so, like I say, this is a digression on 2x2 tables. This is, I hate to say it's going to be sort of a contrived example, because in the weather data set, I sort of don't have two categorical variables that I'm particularly interested in, like an exposure with 2 levels and a response with 2 levels. So I've got to start out by creating something like that. So what I'm going to do is take my weather data frame, and I'm first going to get rid of everything that isn't in Waikiki. So let's say name not equal to Waikiki, Hawaii. So I should be left with Central Park and Waterhole. And I'm going to think of Central Park and Waterhole as my exposure. And now I need to create a response variable. And I'm going to create a response variable that is whether or not the day that we have observed is cold. And the structure that I'm going to use to create this variable, there are a couple of ways that I could do this. I'm going to use case when. And case when sort of says, given this condition, use this output level, and given this condition, use this output level. And so what I'm going to say here is, if the daily maximum temperature is less than, let's say, 5, then I want the cold variable to say cold. And if the Tmax variable is greater than or equal to 5, I'm going to say that this is not cold. And so the notation here, the syntax is a little bit strange. I have a condition here, Tmax less than 5. The tilde says, when this is true in my data set, when Tmax is less than 5, put this into my cold variable. And when this condition is true, put in this one. And it's sort of helpful to have a final thing that just says, if I've missed some case, just put in some missing value, put in something to be clear. I shouldn't miss anything given this condition, but I'm sort of pointing this out as best practice. All right, so I've got this data set here, and it's cold on January 1st, and it's not cold on January 5th. It's not cold on January 1st, and it's cold on January 5th. I'm not sure if I said that the right way the first time around, but great, it's -9, it's really cold. All right, so I've got now an exposure, name, and an outcome cold, and I might be interested in sort of counting up the two combinations there. And so what we've seen, for example, is you can use, and I would use, group by first name and then cold, and then summarize so that I get, let's just say count is equal to n. And I have here kind of everything that goes into a 2x2 table. I've sort of not organized it in the same way. I could put cold as a column row and not cold as a column and not cold as a column, and organize this a little bit differently. But this is one way that you could get to the data that exists in a 2x2 table. You might think to yourself, well, really what I would like to do is actually get a 2x2 table. And like I say, we could reorganize this by pivot wider and doing some other things, and I'm not really going to worry about that. First, because I don't think it's super helpful now, and second, because I'm going to show you a quicker way to do that. So let's sort of get to our contrived example again here, and the function that I would use is janitor : table, and it's tabyl, because they didn't want it to be table. That would sort of override R's default thing in a way that they didn't want to do. So we've got this weird spelling of table, which sort of bothers me, but you can't win everything. And so I'm going to create a table for name and cold, and it spits this out in the way that you might want it to, with sort of the exposure and response and your cell counts in both of these places. So that's how you might go about creating a 2x2 table, or a whatever by whatever table. Is I would use janitor table, or probably more likely group by and summarize, and then do some pivoting beyond that. I'm mentioning this again, don't use the table function in the same way that here don't use the table function. Here, don't use the table function. If you use table, you're going to get something that isn't a data frame, and that is exceptionally hard to work with. This produces a data frame, and if you needed to do something else with it, you could do that. So I think that's, if you have to create a 2x2 table, this is the structure that I would use to do it. But I got to say, is a weird thing for somebody in a school of public health to say. I don't create 2x2 tables really pretty much ever, right? Like I feel like when I was a student, I thought I was going to be computing 2x2 tables by like cross multiplying and dividing all the time, and I just never do that. If you need to get an odds ratio, fit a logistic regression, right? Like a reasonable person. Do regression and put in the confounders that you know that exist, and so just do that as the way you're going to do things. So I can maybe count on one hand the number of times that I've really needed to use a 2x2 table. It just doesn't come up that often. But since I don't know, if not alone in that, like there aren't too many other people who are who are not strongly pro 2x2 table. So this is how you would do it in a school of public health if you need to. So I'm gonna move on real quick before I get myself into trouble. So let me. 2x2 tables are pretty okay, I guess. All right, so what I'm going to do next is return to group by and summarize, but I'm going to start doing things that are a little bit more general than counting. That's kind of where we are now. So how can we do general summaries in this sort of a context? So I'm going to return to my weather data frame, and I'm not going to do this cold yes or no business anymore. What I'm going to do is just group by month, and then I'm going to start summarizing things. And I've seen, you can count the number of days, you can count the number of distinct days, but I'm going to start doing something that's a little bit different. So here, let's suppose I wanted to get the mean Tmax. Well, let's just take the mean of the Tmax variable. Okay, let me try this first. So now I have computed in January, the average max temperature is 10. In February, it's 12, and so on. Here, there's a missing value. If you go into the raw data set, let me see if we can, weather df, view, in Tmax, somewhere down in like June of in Waikiki in June, there's probably a quicker way to find this. There are some missing values. So here you can see in Tmin, for example, in Waikiki, you've got some missing values sometimes. I'm not entirely sure why. Weather station, they didn't feel like calling it in that day or something. If I was going to do a more formal analysis, I would probably want to check on that. But there are missing values in sometimes precipitation and sometimes Tmax and sometimes Tmin. So here I'm going to say if you want to get rid of those missing values, you can use the same kind of a thing that you would in the mean generally. NARM is true, and we can compute this and get the average temperature in each month. Now again, I'm saying what I need to call my variable, and then I am defining whatever transformation I want to have here. And I can do this for multiple things. I could get the mean precipitation to say mean precipitation, and let's still do NARM is true. What else might we want? Let's try the median. Tmin, so let's take the median of the Tmin variable. Right, and I guess I can do get rid of the missing stuff here. Okay. All right, so now I've got in each of these months a variety of numeric summaries that I might be interested in. And so again, group by and summarize lets you define multiple outcomes that you might be interested in summarizing across. We could also take this and say, let's group first by name and then by month, and I get a much bigger table, 36 rows, and I get the average Tmax in Central Park. You start to see the seasonality effect here. It's cold in the winter and hot in the summer, and like it starts to show up a little bit differently here. I'm going to return to this example. Well, I was going to say I'll return to this example shortly, but let's go directly from here. So one of the points that I've made is, so first you can do lots of summaries. The next thing that I'm going to say is this is a data frame. And why that matters is I can take this same code, take my result, and put it directly into ggplot. And let's say on the x-axis, I have month, And on the y-axis, I have mean Tmax, and my color is defined by name. And let's add a geometry here, geon point. And while we're at it, let's do geon line too. So now I have taken what had been an original data set and ended up with something that's a little bit easier to view. Now, you could argue, is this really necessary? I'm going to delete all of that group by and summarize. I could create, I think, no, sorry. If I delete this stuff in the middle, mean Tmax doesn't exist. But if I just looked at Tmax, I can end up with, gosh, something weird here. A slightly different version of this plot where I could, with some modifications, it's not just as easy as deleting the stuff out of the middle, but with some modifications, I could look at every single day and have lines connecting each of those. And sometimes this is the view of your data that you actually want to have, and sometimes this is the view of the data that you want to have, depending on what you're trying to communicate and how much of your raw data you're trying to display. I'm not really trying to make a point about which of these plots is better exactly. I would probably default to the one that has all the data points. Whatever. The point that I'm trying to make here is that because group by and summarize produces a data frame, you can then go directly into other things that might exist in the tidyverse. You can filter and you can select and you can do some mutate, you can make some plots, you can do other things. And sometimes this sort of first level distillation, the first level quantification, is an important component of doing whatever analysis you're going to do. So we can make a plot. All right, the last thing that I'm going to point out in the context of multiple summaries, second to last thing that I'm going to point out in the context of multiple summaries is suppose you want to summarize many columns in the same way. All right, so what I mean here is, suppose I have my weather data frame, and then I group by, let's do name and month, just because we can. And then I wanted to summarize, and I wanted to take the mean precipitation, the mean Tmin, the mean Tmax, right? I wanted to take average of this, and average of this, and average of this. I could write out mean Tmax, mean precipitation, mean Tmin, and then do mean, 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 and all of this, right? If you are going to apply the same summarizing function to multiple columns, there's a helpful function that sort of just came out in dplyr, which is to do the following thing. So I'm going to summarize across precipitation to Tmin, and I'm going to use the mean function. And that spits out this whole thing, right? So here I have computed the mean precipitation in Central Park, the mean Tmax in Central Park, the mean Tmin in Central Park. And so it's sort of doing this computation for each of those outcome variables that I have listed in this range. You can list multiple things. You can find numeric variables. There are a couple of different ways that you can use across, but it's sort of saying for each of these columns, use this summary, and it spits out something that's maybe helpful to have here. So that I think is maybe a helpful thing to have. And then my final point is just a reminder, sometimes your data, your results are easier to read in another format. All right. So what I mean by that is, let's take my weather data frame and group by name and month, and summarize. And here, let's just say mean Tmax is the mean of Tmax, right? This is a hard thing to read. And like I started to show earlier when I was making a 2x2 table, if you wanted somebody else to look at this, there are maybe better ways that you could format this for a reader. So what I'm going to do is pivot wider. Again, I'm able to pivot wider because I've got a data frame. This is just really, really fantastic. And so let's take names from name and values from month, sorry, mean Tmax. Is this going to work? Yeah. So now I've got the names came from here, and the values in my table came from here, and then my row names are sort of whatever's left in my data set. So I've got month, January, February, March up through December, Central Park, Waikiki, and Waterhole, and I can sort of view a little bit more easily what's going on in each of these months. You can, this is another sort of helpful trick, if you're putting a table in a document for somebody else to read, in the knitter package there is the cable function. And what that's going to do is format the results in a way that's a little bit easier to read if you have a R Markdown document or the result of an R Markdown document. And I'm going to even put here, let's just say digits equals 3, right? Actually, that's way too many after the decimal point. Let's say round to the nearest 1 digit. And so this is like I say, you can group by, you can summarize, you can formulate your results in a slightly nicer way, you can print them in a way that's a little bit neater. So let me knit this first so that you can see what I'm talking about. So now down here at the very end, it's a little bit cut off, but this table is a little bit easier to read. It's more nicely formatted than just like our output might be. And that's what I mean by knitter cable. So we're doing great. I guess the other thing that I'll point out, because I put that code snippet at the beginning, I've got this minimal theme with the Viridis color palette, and it's sort of working by default in the way that I'm happy with. All right, this was general summaries. Sweet. All right, so group by and summarize are going to help you out a lot. What I'm going to talk about sort of briefly next is another function that is affected by group by, and that's group by and mutate. I'm not being real consistent here. Okay, so what I've said is you can, when you group by something, you can summarize and collapse it down until you have sort of one new observation per group that you had previously defined. But mutate also respects this grouping structure, and this is one of the ways where if you've forgotten that you've grouped, you can get into a little bit of trouble, but it turns out to be a really handy tool to have. And so let's sort of take a look at why this might be the case. I'm going to take my weather data frame, and I'm going to group by name. And now instead of summarizing, I'm going to mutate. And I'm gonna start out in this mutate thing by looking at mean Tmax, and this is going to take the mean of Tmax, and I'm going to say na.rm is true. So this looks like something that I would do with summarize, but instead of summarizing, instead of getting one observation per name, what I'm going to end up with here is a data frame that is the same size as weather df with a new column, and that new column is defined in this way. So if I run this whole thing, I have a data frame, it's still got my groups, it's still got all these rows, I've added a column for mean Tmax. And what's helpful about having this mean Tmax, in particular in the context of this grouping structure, is that if I view this whole thing, I get one mean Tmax 17.3 for Central Park, I get a different mean Tmax for Waikiki, and a different mean Tmax for Waterhole. So the grouping has sort of said, when you do this mutate, you're going to compute some observation, you're going to define a new variable, but you're going to define that new variable, if it matters, according to this group first, and then this group, and then this group. And you might sort of say, all right, well, why do I care about this? Right? You might, for example, want to do something like centering. You might want to remove some vertical distance between these things. So let's do centered Tmax is whatever the Tmax variable is minus this mean Tmax. And now I have new Tmax observations, the centered Tmax, that is a location-specific centering process, right? I haven't sort of subtracted the same mean from everybody. I have subtracted Waikiki's mean from Waikiki's observations, and same for Central Park, and same for Waterhole. And just to sort of illustrate that real quick, let's make a quick plot. X is date, and Y is centered Tmax. Oh, and I need to define a color. And let's add points. A plus instead of a pipe. Thank you. Right, so here, everything, each location is now centered around 0. Here's Waikiki, centered around 0. Here's Waterhole, centered around 0. Here's Central Park, centered around 0. I've done a pairing here. I have grouped first and then mutated, and done that mutate in a way that works one group at a time. And this group mutating turns out to be a sort of a helpful thing to know, sort of a helpful thing to be able to do in a variety of situations. Again, it is one of these ways that if you have forgotten that you have grouped, it can get you into a little bit of trouble. So I'm gonna jump straight into the next little bit here. That is, what about window functions? So when I took the mean here, it took every Tmax observation and it produced one mean value based on that Tmax observation, and then plugged that in for each row in my data set, right? So if you sort of remember, I computed the mean for 365 days and I plugged in that value for all 365 rows here, right? But it was sort of 365 days in and then one value out repeated everywhere. Window functions work a little bit differently in the sense that you put in 365 values and it spits out 365 values, and those might be different values. And so there are a couple of, I think, helpful window functions to think about first. The first of these is, and maybe the main one that I'll take a look at, is a ranking function. So if I want the weather data frame and I want to pipe this into group by, let's do name and month. And I'm going to mutate again, where I want to do the temperature ranking according to, I want to define a ranking according to the min rank Tmax. And here, min rank is sort of a method for defining ranks and the ties that go along with those things. So here I have, for example, in my temperature rank, I have put in for every month the Tmax values, and it says this is the 22nd lowest value in that month. This is the 12th lowest value. Here are the 5, actually all in a row, the 5th, 4th, 3rd, 2nd, and 1st coldest days in this month, right? So I could, for example, here say, all right, let's filter so that temp rank is equal to 1. If I wanted to get the coldest day in each month, and just sort of out of curiosity, the coldest day in Waikiki in January was 24 degrees Celsius. That's the coldest day. That's pretty pleasant. All right, so this is the kind of thing that you can do. Again, what I've done here is a group by first, and then I've used a function inside of mutate that takes all of the Tmaxes, and instead of sort of computing a mean and repeating that everywhere, it's spitting out the rank that goes along with each of those things. If you want to put this in the opposite order, you could do descending Tmax. I think this is the right structure. Yeah, so now ranked in the opposite direction, I use the minimum rank but descend everything. And so here I'm going to go from the first is now the 31st and 30th, 29th, so on. I'm sort of counting from the bottom up rather than from the top down, and that can be helpful. And again, you could use this to do some other kind of manipulation, some filtering. So ranking. And then the other window function that I find a little bit helpful is things that are lagged a little bit. And what I mean by lagged is, can I take all of these observations and then copy them over to a new variable and shift it down by 1. This only makes sense if your data are in an order where that sort of shift over and then lag makes sense, but it happens often enough that it's a helpful thing to see. So what I mean by lag is the following. I'm going to take my weather data frame and I'm going to focus only on name. So let's group by name. And I'm going to mutate again here, and I'm going to define something that is the temperature change. I guess first I'll do lag temperature, and the lag temperature, let's look at lag Tmax first. So what lag temperature does is it says, here's 8.9, here's 5, here's 6.1, and if I wanted to lag by 1, I'm going to take 8.9 and copy it over and shift everything down by 1. There's no observation before this one in this data set. So my first lag here is missing, but everything else is sort of one row off. And I think you can do lags in other directions, compute lagged or leading values. So if you want to sort of shift in the other way, you can lead. If you wanted to lag by 5, you can do that, right? So we get 8, 5, and so on. This lagging is helpful. Often if you want to sort of compute like what is the change from this day to the next day, what is like the biggest change from one day to the next, what is like how much do these things change, using lags does yesterday's temperature predict today's temperature, these kinds of lagged information come up from time to time. And so I could, for example, do like temperature change let's do T max minus lag T max. And so here, the change from this day to the next is whatever it decreased by 3 degrees, increased by 1 degree, and so on from there. And I could, I guess, if I wanted to, from here, start to do some summarizing as well. So I might, just because I'm curious, compute a couple of summaries. Summarize. Let's do temp change max is the maximum, not ranked. I'm not doing like a min rank or a max rank. I'm just computing the absolute maximum temp change. And since I've got some missings floating around in here, I'm going to do NARM is true, get rid of those. Okay, and then I guess maybe the next thing that I'm going to do, let's do temp change standard deviation. And here the standard deviation of temp change NARM is true. So I've got now a couple of things, right? So the biggest one-day change in max temperature in Central Park was 12 degrees. 12 degrees Celsius. That's a pretty big shift. Waterhole also was 8 degrees. That also sort of seems like a pretty big shift. Waikiki, I'm a little bit surprised by. But I guess sort of if you look closely, there is in Waikiki one day here that was sort of, this is the centered view of things. There's one day here that seems like it increased kind of a lot. That's 6.7. That's probably the day that increased the most, right? And I can't see visually where this max exists. We could probably do some way of identifying that if we were really interested. But what I find helpful about this is if, for example, somebody had started out and said, can you please compute the day-to-day temperature variability, the day-to-day standard deviation in temperatures for each of these 3 weather stations over the course of a year, you might think, oh, that sounds like a really, really hard problem. And here we've done that in 6 lines of code. 6 if you don't count like this parentheses, right? Like we've done this in a really, really fast sort of a process. And so I guess the take-home message here is not so much that, the temperature doesn't really vary much day to day in Waikiki. I think that's neat. What's great about this example from a coding perspective is that we are answering a relatively complex question that we might be interested in, and we're doing it in a way that is clear and coherent in a pretty short amount of code. And so this is the kind of thing that I feel like pretty good about when it comes to doing this kind of exploratory analysis. So pat yourself on the back. You can compute like daily temperature changes and variations of those things in 5 lines of code. You're doing great. All right, so let me commit again real quick. What did we do? What did we do? We got group by and mutate is what we did. We also did some neat summaries. Okay. So the next thing that I'm going to just mention here at the sort of last bit of this lecture is a quick note. Summarize only gets you so far. What I mean by that is in all of the summarizations that we've done, we've grouped here and then we've summarized using the max, or we've summarized using the standard deviation or the min or the mean or the IQR or the variance or something like this. all of those summaries take some variable as an input, often a single variable, not necessarily, but often a single variable as an input, and produce a single scalar summary, just a one number summary of the things that are going on. That is a really powerful framework. It is a useful tool to have. At the very far end, it starts to not be quite enough to do some kinds of exploratory analyses that you might want to do. And what I mean by that is if we wanted to, for example, take our weather data frame and ask, I guess let me look just at the weather data frame. If we wanted to ask, what is the regression coefficient regressing Tmax on Tmin, and we want to do that for Central Park and Waikiki and Waterhole separately, and then we want to repeat that, grouping by name and month, and we had 100 weather stations. That's a hard problem. And the hard problem there isn't the grouping structure. The hard problem is how do you do that regression, and then how do you pull the results out of that. And this process, the summarize, will get you a lot of things, but it won't get you quite to being able to do a summary that's more complicated than just spitting out single numbers. So for now, the same structure works. This idea you want to do like group by and some kind of a summarize, that gets you a really, really far distance in terms of exploratory analysis. Someday we're going to have to do something a little bit more complicated than that, but this is really good for now. So that's the end of this video. That's the end of the third in this collection of 3 videos on visualization and exploratory numeric analysis. So I'm going to wrap it up, but I feel like at the end of each of these blocks, I'm reminded of how much progress you're making and how quickly you're doing it. And I think it can feel like you are almost overwhelmed by how much information is happening all at once. But again, like if you're sort of following along in sequence, we've gone from naming code, naming variables and files, and then using R Markdown and using Git and GitHub and reading in data and then manipulating it and tidying it and making plots and making those plots fancy, and now doing exploratory analyses. We're covering an awful lot of ground, and I am really happy that you're sticking with it, and I'm sure that you are learning an awful lot. Sometimes it takes a little bit of time for everything to congeal, but I'm happy that you're sticking with it. So thank you very much for that. Great work on this, and that's it for now.